All right, good morning, everyone. My name is Mark Proctor. I'm the Drools co-founder and the platform architect for the Drools and jBPM projects, which leads into the BRMS and BPMS platforms and products. My talk today is really going to be sort of a smorgasbord, a scattering of what's happening around not just Drools, really, but the overall ecosystem that supports that. So, quick summary, sort of where are we? In mid-2013, this is where we were. So this was with the Workbench, and it was a good proof of concept. There's some nice things there, but everyone knows we had great vision, but we didn't really have the capability to, or the capacity to execute it to the high enough standard. Here, the most recent release, community release, is 6.4. So as I say, in 2013, we released 6.0. In 2016, 6.4. Massive stability upgrades. We get some good feedback people now. They're very happy with the stability of the project. We did an upgrade to Patternfly, which I'm going to talk a little bit more about later. And this has given it a much better polish to how it looks. And obviously, it's massively improved over the screen you saw from the 5 series. 6.4 also included a fully redesigned executable server, which I'm going to demonstrate later. And we improved the augmented process runtime views on the jBPM side. So you'll often hear this word key, stands for knowledge is everything, and it's just to try and bring an umbrella around the projects which we all belong to. A very crude diagram, apologize about the colors. So this is the family, sort of the makeup and how they feed into. You have, on the left side, you have the web stack, Git, Errai, UberFire, Commons, which includes things like forms, data modeler. In the middle, you have the runtimes for Drools and Optiplanner. And on the right, you have DashBuilder and jBPM. The web tools feeds into Drools WB. Drools and Optiplanner feed into Drools WB. W means Workbench. The Drools WB Workbench feeds into Key WB. It's all layered. It's all modular, it's all layered. And obviously, to make up Key WB, the complete aggregate Workbench, that feeds in DashBuilder and jBPM. So I'm going to talk very briefly about the product maturity model. We're trying to really get our projects and thus the products to the next level in usability. You know, in 2013, we had just 10 people on our entire group. We've now more than tripled the size of that. We have added a UXD group, so user experience and design group. A number of people there now dedicated to our product. That didn't exist in 2013. The QE team also is much more bigger. So we're really now trying to, for the 7 series, see if we can get up to the product maturity model to a point where I think we can be proud of what we're doing. And I'm going to try and give you an insight into some of the things that we're going to be delivering for 7 series over the next 9 to 12 months. As part of this product maturity model, we've been working with UXD to develop personas. So when we're doing the UXD now, when we're doing the designs of our products, we have to think about who's it for, how they're going to use it, and the user experience group are there to sort of really make sure we think about these things and they emanate throughout all of our designs. And they developed these personas. I won't go into too much details about these, but these are personas specific to the Drools and jBPM products, and they allow us to identify the software, the parts of the software that we're working on. So here's Deepak, which is the remote Java developer, Cameron, which is the citizen developer, and Amy, which is associate process manager. Why am I showing these things to you? Because I'm trying to get across that Red Hat is really investing in the whole usability. It's our #1 priority, and the whole of engineering is now dedicated towards making this happen. The UXD are really doing a fantastic job with us to move everything we're doing to the next level. And senior process manager, Paula. Obviously, this is a Drools talk, and I'm going to be talking about the Drools ecosystem. Case management is really a jBPM thing, a workflow thing, but I'm going to bring it together I'm going to mention it very briefly. As part of trying to improve the overall usability, we want to try and move the whole platform to be able to deliver low-code solutions for self-service applications, sort of an app dev environment. And case management is a very convenient way to, it's a framework which brings all this together end to end. So it allows you to model your applications, to model what's going on, and it will basically publish fully working applications if you follow this low-code route. So this is sort of a generated, well, this is a UXD provided diagram, which is the sort of thing which generates for a medical product. And case management typically looks like this. For each of the available cases for your application, they have stages, and each stage has a number of tasks. Those tasks could be a workflow, they could be a decision, they could be anything, and they have subtasks. So this is something that's being worked on for the 7 series, which will provide a framework to tie all together to be able to deliver low-code applications. So I'm going to go into usability and pattern fly now. So this is the Workbench in the 6 series. And now you can see there's the 7, well, actually the 6.4 upgraded to pattern fly. So already you can start to see this in the 6 series. And it's, everything is much better stylized. It's more compact, it's more clear. And this aligns with all of the Red Hat product portfolio. So pattern fly is a dedicated group of Red Hat to make sure all our products look fantastic and they all look and work consistently together. It's a fantastic effort. So here's the jBPM reports. This is the old version. And now you can see the new version. Again, this is in the 6.4. This has all been pattern fly enabled and obeys pattern fly best practices. The execution server is a new component, so I can't show that to you before. But already you can start to see the designs now are so much better than what you saw in 2013. It looks professional. It looks good. It's something we can start to be proud of. I'm going to talk very briefly about the web stack, because this is what's enabling everything around our low-code application development environments and how we're going to generate some applications. And it will become relevant when you see what I'm going to show you with some of the form stuff. So the 7 series is going to be targeting GWT 2.8. We use Errai. So we've learned a lot, and we made a lot of mistakes with GWT. But we are a Java group. It is a tool that works very well for us. We are JEE. And we like type safety, we like tooling, it works well for our group. Errai is a layer that builds on top of GWT that actually fixes all the problems. It's taken us a long time to get there, but now with Errai, we're able to develop rapid application of our web front ends and to be able to work directly with UXD because we're providing HTML templates and working directly off HTML templates, similar to AngularJS. So if you think about it, Errai is like AngularJS, but for Java developers who want type safety and want it to work directly with Pojos. So this is Errai UI. This is how it will bind your forms to your HTML. So you have your HTML template down the bottom on the right there. You have your form there. You bind the fields, and that's it. It's ready to go. So this means UXD now can provide us, that's our user experience group, can provide us the HTML and HTML templates, and it works directly against our code. So this makes it really easy now for us to be able to have the other groups who specialize in design provide us working HTML, and for us to then be able to deliver a product from that. And that's a key part of our improving the user experience of our product. I won't go into too much about Errai, but this is a little bit about the data bindings. There's other presentations about Errai if you want to find them. UberFire is built on top of Errai. This is our Workbench and rich client platform. It delivers perspectives like whole pages and named perspectives. It delivers screens, which are small little sort of divs on the page. That's a form of a component. We have a number of subcomponents for this, such as the page composer, which I'm going to demonstrate, security permissions. We're working on sort of a centralized preferences service. So I'm going to get straight into Form Builder. So what we want to do is enable people to be able to build applications end-to-end within a tooling, to be able to author, build, deploy an entire working application. And even if you've got a rule application, you've still got to be able to gather data and submit it to your rule server. So you need to be able to have forms. So we want people to be able to very quickly be able to build forms. And sorry, I was supposed to have 2 slides split there. On the behind it, you can. Anyway, this is the old form system, and it's very limited in that it only allows you to have rows of things. You couldn't have any spanning of cells, which made it very difficult to get complex layouts. But that's what's in the 6 series. So we've done a huge investment to build a really, I think it's a fabulous tool now. It's one of our shining pieces, I think, in the 7 series. So I'm going to be able to show a video of this. We've moved to Bootstrap grid views. This allowed us to be able to build sophisticated layouts, and allowed us, because it's responsive design, means that it'll work on tablet and on mobile, which I'll demonstrate to you in a moment. The problem with Bootstrap grid views is that they're actually quite difficult to do. You have to lay out your structure first and then put your components inside of them. So if you've used, for instance, lay it out, if you want to compose a page, you have to decide your structure first, and then you can drag your content into it. If you decide you want to change the structure, you have to remove all the content and put it back in again. It's very difficult to be able to use Bootstrap building tools and have a sort of a dynamic, flexible grid system. So we were working on the ability to have that dynamic, flexible, adaptive grid system, almost like it's gridless. You don't know it's there. You just drag your components behind, and it builds the appropriate Bootstrap grid for you. Everything within our framework, within our form systems, uses Pojos. It uses JPA for annotations, and even actually, if your beans have a bean validator on there, is not null, is a valid date, match a certain pattern, all of this will actually be compiled down because it's GWT, will run in the browser. So it means that I don't have to, literally just my code that I use to write my beans, to write my business logic, I write it once, I bind it to the form, and it goes straight away. And I'm going to demonstrate some of this to you. I have a little video now of the form builder. It just runs for, this is the longest video I have, for about 3 minutes. So first of all, it's going to create a subform. So the subform it's creating is the address. And what it's going to try and demonstrate here really is that we can get nice positioning. Everything, when you drag it across, highlights where it can go, and whether it's going to be nested or below, to the right and above. So it makes it easy to be able to sort of nest inwards or position to the left or to the right via the guides. And underneath, this is dynamically calculating the Bootstrap grid view you need underneath. And it's just showing you can resize your columns. So this is resizing your grid views for you underneath. The little buttons along the top would allow you to preview in desktop, tablet, and mobile device. Actually, they're not shown in this video, but in the next video, you'll be able to see those working. So it's just saving in the video. And again, everything here you can see is part of the Patternfly UI upgrade. That's why it's looking much better. The authoring perspective you see here is going to change completely, actually. We've got fantastic new designs from the user experience group, and they've really cracked how to improve the authoring perspective, get it much more content-orientated. I don't have anything to show there, but expect that to change in the 7 series. So now it's just building the outer form, which is the user. The user has the nested address form, so it built the address form first. And so we have the user, and the user has an address, just populating the fields that you can see to get it going. Takes a little while to run. And that's it, that's your form built. So now, you're just going to open up and make a change, I think. So it's just showing that if you make a change in a nested form, it will still be visible in the parent form. And building and deploying it. And there's the working form. So this is like a preview to be able to work in with the form. So that's it. So literally we've just built and deployed and made it visible a quite sophisticated form-based system. And the sped up video is like 3 minutes, but you see it's a massive improvement over what we delivered in the 7 series. It's just creating some new data for the rows. Okay. So what I'm going to show now is that form you just saw that was built within the application. The preview you saw was within the Workbench itself, but obviously we want to be able to deploy this to OpenShift. I built my forms, which may use a REST service to call into my decision service. So OpenShift Origin has an all-in-one JVM virtual machine, and you can use this, install on your machine, to be able to play around with OpenShift. So I have another video now, which I'll just start. And this is going to show the form we just saw within the tooling. And this is our 7 series tooling, and it's going to provision the... Okay. It's going to provision that form first to... I can't remember which one, to Wildfly, and then run it in Wildfly, and then it's going to provision it to OpenShift, because there's providers, so there's different providers for the forms. And he's just going to change a couple of the fields, so you can see that those changes are reflected in the deployed application. Selecting the OpenShift provider. Again, this is all within the 7 series. Setting the provider name. This is so it knows how to provision to. It's deploying the application now. Selecting the repository, and it's deploying it. You can see along the bottom there, that gives you an indication of where it's going, sort of the pipeline for deployments, the provisioning. And that will actually work with CI/CD, continuous integration and continuous development, if those facilities are available. He's changing a couple of the fields, changing some of the names, and you'll be able to see that reflected in the deployments. Changing the positioning. Redeploying it. And now going to do a Wildfly deployment. So imagine you're doing a mortgage application. You can now use your form. You can build your form in this, and you can provision that form, and that form can actually work against a rule service, which I will get onto that next, how the rule service works. It's just shifting back and forth between OpenShift now, showing that it's actually provisioned. I think now it's actually taking a little longer there because it actually has to compile all the sources as it deploys to OpenShift. And you can see as it goes through the pipeline, it indicates what's going on. So you get full feedback as it's moving through the OpenShift pipeline. It's got the link, and he's going to check the link. And there you go, there's the running. That is now that same form, fully provisioned, deployed, and made available on OpenShift. So in here now, it's just JPA backend. It's just saved to a database. But if you wanted to, and what we will allow it to do, is submit those forms directly to a rule execution server. That bit of plumbing is not quite done yet. It is possible to do it now because this is a Pojo project. You can open it up in Eclipse. Everything that goes on there is JPA, so you get JPA callbacks, and you can put hooks into onSave and submit it to an execution server to add the code yourself. That's the great thing about, although this is all tooled and the tooling does everything for you, it's still a Pojo project, which means you can go into Eclipse and IntelliJ and augment the Java beans as you'd want to do normally and change the dependencies. You're not limited by the tooling just enables you. Again, this is the OpenShift project tooling you're seeing there, that's switching to. He's just demonstrating that it's got the changed field names when he did the deployments. Okay. So I'm going to talk a little bit now about DashBuilder and the page composer. So DashBuilder is our key performance indicator reporting tool. It can work with, well, here's an example of it. This is a DashBuilder page working against a Git repository. And it can has adapters, and you can provide adapters for anything. So this is giving commits, it's providing a breakdown of people's work, of what's going on in a project. And we use this as part of our contributor form within our system. Here's a DashBuilder example where it's showing backlog per customer, top sales, these are KPIs, and sales backlog and customers again on the side. I mentioned before that we reuse DashBuilder for our jBPM runtime views. You can see it here, and it's starting to look fantastic now. The core of DashBuilder is what we call the data set. It has 4 out-of-the-box providers, SQL, Beans, the Java class, CSV, and Elasticsearch, but the interfaces there you can provide your own. And this is the configuration for each one of those providers. So imagine you're doing your end-to-end application. You build your form to submit your mortgage application, and as you're submitting your mortgage applications and you're approving them, you're recording this in a database. And you want to be able to produce a report on it to find out what are your key performance indicators. What's your performance of number of applications declined, approved, based by region. So the DashBuilder can use that within your business application. This is getting into the preview. When you want to display the information, you can select the columns you want. And this is the advanced preview. DashBuilder has caching both midway and on the client. It has both pull and push-based semantics, which all can be configured. And this is the Dataset Explorer that's within the tooling. And it's a little visual diagram to try and explain a little bit how the backend works and the sort of flow, depending on whether you have caching on or caching off. I won't go into too much details on that now. And I've got a little video here. Okay. One of the reasons why I want to show this DashBuilder video is it's going to, again, demonstrate that the same technology we use to be able to build forms, we can use to build pages. This is an HTML widget. So the same technology now can be used to build entire pages. That's what DashBuilder does. It builds a perspective. And we're going to build a perspective now with DashBuilder. We're going to put some charts, we're going to put some HTML on there, and we're going to make them available within the Workbench. Because the Workbench itself can also be a deployed application. It's added 3 components on a page. It's adding another one on now. Again, it's just trying to demonstrate that it's got nice, sophisticated layout capabilities in regards to nesting and aligning and spanning. He's gone into, there you go, he's gone into the app directory and he's showing you the available perspective. So it's just built that page and made it available live. The data sets that it uses were pre-made. I didn't show you the creation of the data sets. He's changing the page, adding some new content in there, repositioning it, putting a logo in there. And we're going to see that page has been redeployed. You can put pages into the app directory. And you can also add them directly to the menu at the top. So they can either go into the app directory, which is like a tree structure for your available perspectives and the perspectives you built, or you can put them into the menus. All things that you build are secured by permission, so you can control who can see what. So when you build your pages, and then you just say literally in a minute and a half, we built a custom page with sophisticated layouts using DashBuilder for reporting, mixing charts and HTML. Although you don't see it here, in the 7 series, we want you to be able to use process views and task lists to be able to compose the pages you want. And this same technology is being used for case management. So the case management would generate pages with the appropriate information that you need for that case. I think what the video does now, it's going to demonstrate resizing. Because we're using Bootstrap grid views, everything resizes correctly. So it's resizing for tablets, resizing for mobile, and it's doing that with what we call responsive design. And again, this is all, you get it for free out of the box when you use our builder tools. And it's just demonstrating that when you're in Chrome DevTools, that it also works. So there's Chrome DevTools now just repositioning the signs and showing it that it's resizing correctly. Okay, that's finished. It did show it to you, but I missed it when it pressed 3 buttons at the top, and it showed you the preview for the different views. So it showed 3 different ways to see the resizing. But it's all looking pretty sophisticated now. We have a new user group and admin tool. And what I'm trying to get across to you here is the sort of maturity that 7Cs will have compared to what we've had historically. So this is a very short video showing you can add users, groups, and roles, and everything now is done graphically. I don't know if you remember, if you used the 6 series, you had to go to command line and you had to do add user. It wasn't user-friendly. It was quite hard to set up. Again, all of our UI now goes through the user experience group to make sure that what we produce is nice. And then get on to, there's a permissions one. So that was just adding users and groups. It's not that interesting, but I just want to show the maturity of the product. So permissions is now going to show you how you secure one of the pages you deploy. So when you have the roles, you have the home perspective, which is actually when that person with that role logs in, which is the perspective they go to when they first log in. You have some priorities, which is how you resolve some conflicts. And then it's just going to show you adding perspectives and changing the securities for read updates. Can this person change the layout of the perspective? Can they view it? That type of stuff. If you don't have permission to view a perspective, if it's in the menu, you don't see it in the menu system. Okay, that one's done. I'm going to get onto the execution server now. So the execution server is something that we have built that allows you to be able to author your rules, your workflow, your OptiPlanner optimizations, and within the Workbench, provision those and run those all tooled. Without you having to do everything. It's out of the box, and this will also be out of the box on OpenShift. So I've got a video now, and it's also going to demonstrate something else we're working on, which is what we call tabular chaining. This is the new project. It's going to check out an existing project. So tabular chaining is for a decision table, connecting different decision tables together to create a flow. We're working towards the decision model notation specification, which has something called DRDs or DRGs, decision requirement diagrams. And this is the first basis for this. It's just showing you I've imported my project from GitHub. I'm just going to show you the models. And it's a very simple thing. It wants to calculate the holiday entitlement for an employee based upon years of service. So there's my first decision table. It's a very simple one. This is my aggregate. It's just showing that the new sort of look and feel. This is all now built on Canvas. And you're going to start to see why we've moved from using HTML tables to Canvas tables. And it also scales. The other ones struggle to scale beyond 200 or 300 rows. This scales infinitely. We've got it to go into tens of thousands of rows. So now I've got 2 decision tables on there. I've got 3. They can all be panned and zoomed. I can zoom out. You can edit at any point of zoom, and there's a quick zoom in as well. This is lab stuff, so this has still got a long way to go before we're happy with it yet, but it's shown this is really quite smart compared to what we had before. So there's quick zoom, and you can also traverse the links to go to the link table. And the way this works, of course, is that you have extra 5 days, extra 3 days, extra 2 days. Depending on your length of service, you're going to get 5 days, 3 days, 2 days. And that's aggregates. So after so many days, you'll get 3 days. So many years, you get 3 days. So many days, you get 2 days. So many years, you get 5 days. So this is just showing the provisioning now. So within the tooling, I went to deploy, and it literally just provisioned it from in there. I'll just get that ran a bit quick, actually. I'm going to show that last bit again. I was too busy talking. So this is going to form the basis of our decision model notation. So build and deploy, so it creates the jar. And now the jar is available. I can deploy that to my execution server. I have to add the container. I call it vacation. I select my gav. It auto fills it in. I click start. My execution server is now available to receive REST calls. And that's it. So I build my rules. I provision them on the execution server. I click start. And now it can be used directly. Again, this is all tooled. There's nothing else for you to do. And this is just a REST client you could call, shows the commands you should submit to the forms and the results you get back if you were to call that. Right, so I'm going to go a bit more technical now. So I've covered the family, if you like, of the ecosystem, the supporting stuff to allow you to move towards building the rapid application development of applications. In the 6 series, we developed something called the Freak algorithm, which is an evolution of the RETI algorithm trying to address many of the issues within that. The RETI is the algorithm we use during the sort of 3, 4, and 5 series, and it has all of the standard RETI extensions. RETI expected functionality, so node sharing, alpha indexing, beta indexing, tree-based graphs, modify in place, property reactive, subnetworks, backward chaining, lazy truth maintenance, heap-based agenda queue, and dynamic rules, which is a good summary of sort of the capabilities and functionality within the RETI engine. Anyone who's used the RETI algorithm knows that it comes with a number of problems for scalability. When your rules get beyond a certain size, it spends a lot of time just churning around with work that actually just gets wasted, it gets thrown away. And what we wanted to do is move towards a lazy algorithm, a goal-based algorithm that would avoid eagerly evaluating rules which were not likely to fire, and if they don't fire, then I don't need to evaluate them. So we wanted lazy evaluation. We also wanted to have, if it's going to be lazy, we have to be able to have isolated rule evaluation, because I want to say, evaluate this rule now. And we know we wanted to have incremental goal-oriented evaluations, because I want to evaluate this rule, but if the data changes in the future, I want to also be able to still incrementally update it. I don't have to calculate it all again. I want all the advantages of RETI. I just don't want it to evaluate all rules all the time when the data changes. I wanted set-oriented propagations. The reason why I wanted that is that actually that's part of our future research, which is called set-oriented match, which we haven't done yet. But in essence, it means that when you have a join or you have a series of joins, each join joins the incoming data of what we call tuples. As tuples join, they produce child tuples, which then join with the other tuples. When you do matching the join in a tuple space, it's very expensive. But if you know that all of the tuples match a certain index, and there's say 1,000 of those items in the index, you join with the index instead of all of the individual tuples. So that's what set-oriented matches. You join with the sets instead of joining with the tuples. In rule engine terms, we call the difference between tuple space and join space. So that's something, if we can solve set-oriented match, and there are papers on this, it's just trying to get it applied to the data structures we have, it should get significant performance improvements again for people doing large number of joins, large data sets. And we wanted something that was stack-based evaluations with pause and resume. We didn't want to have method recursion and the problems that come with that. We did so many hacks within the RETI algorithm to support, say, backward chaining and lots of other functionality, to have something that was recursively method calling, but would fall back and still be able to go to the next level in the stack. So we wanted something that was properly, truly stack orientated instead of all the hacks we had. To make Freak work, we had to introduce 3 levels of memory. RETI only has 1 level of memory, the node memory. So with the join or the terminal node has 1 point of memory. So that makes it very hard to have any context of the evaluation it's doing. So we introduced 3 points of memory, and I got some diagrams to help you visualize this a bit better in a moment. And you have the node memory, which is the same as RETI. You have the segment memory, which is the nodes which are shared together, and you have the rule memory, which is the path. That is the isolated point of evaluation that I want to be able to do. That's my goal. So here you can see on the left, R1 is A, B, C. So A is my object, sorry, my class, B is my class, C is my class. 3 patterns, R1 when A and B and C. A is what we typically call the left input adapter node. That's why it's got a slightly different coloring there. B and C are your joins. And we have bit masking. So when data comes in on A, we set the bit mask of 1. When data comes in on B, we set the bit mask to 2 for the segment, that is. And when the bit mask comes in for C, we set the point of 4. So this is rule has 1 segment, and there's no sharing, so therefore it doesn't need to have more than any segments. Therefore, the rule itself, or the rule memory, also has its own mask, but it's just a mask with a bit of 1. I'm going to come on to a second why we need these information, because this is what allows us to delay the evaluation. But I first want to explain segments. So now if I was to add a second rule with A, D, and E, A is shared, but D and E is not. So this now creates 3 segments. The first segment, A, is shared. The other 2 segments for B and C and D and E are not shared. The nodes within each segment restarts the segment bit. So in the first one, A, there's only one bit 1. That's the bit mask position. In the other 2 segments, B, D, C, E, both bit mask 1, both bit mask 2. Now though, look at the first segment with A. That is now bit mask 1 for the rule memory. And if you go to the other ones, you can see that's now bit mask 2. I'm going to try and now explain what this actually means. And I know I've switched from something that's tooling based and very easy and gone completely the opposite direction. When the rule engine first starts off, it starts off in actually no rules will evaluate. So you can put all your data in there and it does nothing. It just populates the object memory and there is no evaluation because it needs to be lazy. So if there's no evaluation when I'm inserting my data, how do I know at which point which rules need to be evaluated? And that's where the bit masking comes in. So I know that say, if I just go back to the first one, for R1 to be evaluated, I must have data in A, B, and C. If that data is not there, there's no point scheduling R1, creating a goal, to be evaluated. So when the bit for 1, and the bit for 2, and the bit for 4 are set, that actually will then go up to the rule, and it will set the bit 1. For R1, when bit 1 is set, we know that rule is what we call linked in. So you have this concept of segment linking and rule linking. So when A, B, and C are in, that one segment is linked. Because that rule only has one segment, the rule also becomes linked in. Once the rule is linked in, it can be scheduled for evaluation. It's not evaluated at that point in time, though. Now, if I go to the next one, R1 and R2, if you were to insert A, that segment now becomes linked in. However, neither R1 or R2 are linked in at that point because the second segment of the path for R1 or the second segment for the path for R2 is not linked in. You'd have to have some data for B and C and D and E for that to link in. So let's say we have data for D and E and B come in. Because there's no C, the bit mask for 2 for that segment will not be set. So that segment is not linked in. But because there is D and E, that segment is now linked in. Because the A segment is linked in and then the D and E segment is linked in, R2 now can become linked in as well. So it's a way in which we can very efficiently, because there's bit masks, know when there is data, know when we should request a rule to be evaluated. We can know when something's dirty. So we don't always schedule something to be fired if we've already submitted it. I'm going to, yeah, sure. Actually, no, I'm going to come on to that. Let me come to the next bit, because that's my next. We've changed some of the designs. Okay. I won't go into too much about all the networks, but it's just showing that I add a fourth rule, and I can get more segmentation. And now, on the right side, you can see that for R4 to be able to link in, it has 3 segments, so therefore bit 1, bit 2, bit 4 need to be linked in before R4 is scheduled for evaluation. So I need to have data in A, B, D, F, and G. So we're inserting all our data, it's setting the bit masks, and it may, if all those bit masks become linked, schedule the rule for evaluation. But even at that point, there is no rule evaluation. What scheduling means actually is that it goes onto the agenda, and the agenda has a list of all the linked in rules, and it puts them in order of priority. The priority is based upon, actually, we move this very simply to the position within the file. So position of the file determines the rule ordering. Salience is still obeyed, and we'll take priority over the position of the file, but we recommend people just use file position. And this just shows working with not and exists. You don't really need to understand that side. It's just showing that it supports all of the complex layouts. One of the reasons why we want to have segmentation like this is this concept of partial matches. The way that works with engines is with RETI algorithms is you don't want to have to recalculate the matches that you've made. So if I evaluate, let's go back to the other one, say R4, and then later R3 links in, I don't want to have to recalculate the A and B join. I don't want to have to calculate the B and D join because they're shared. So the segmentation also allows it to share the partial matches so that although R3 might be evaluated, it's not linked in now, but maybe it's linked in later, and it's scheduled for an evaluation later, it doesn't have to reevaluate A, B, and D. It just has to evaluate E. So it's a great way for us to be able to, the segmentation allows us to be able to delay evaluation, but be able to benefit from the previous work done by other rules that have fired before it. I'm going to get onto your question now. We've done a lot of work to improve the thread safety via what we call an internal core state machine. This is going to get onto your question in a moment about when these link in. We made a lot of mistakes from the first design. We put sinks everywhere. We had a bazillion sinks all over the code. Oh, this might not be safe, so we'll put a sink in there. Oh, that might not be safe, we'll put a sink in there. And what happens towards the end of it is that myself or Mario or Edson, none of us could be able to explain the behavior of the application. What is the expected behavior of the rule engine under certain situations? And that's quite frustrating. Even we can't explain what would be the behavior of things. If I was to call a certain sequence of inserts, fire rules, and fire until halt, and a timer went off, what's going to happen there? And it was very ambiguous, and that was a terrible situation to be in. Not only is it ambiguous, because the sync points were all over the place, we kept on getting thread safety issues, and it became like a ship with lots of little holes in it. We're going and putting our fingers in it, but eventually we run out of fingers, and we're using toes, and we realized we had to make a complete change. So we decided the only way to make this work was to introduce an internal state machine. And we wanted to make sure this state machine was really efficient, that minimizes the number of syncs it has to go through, and that actually we only wanted to have one point within all code base that was synchronized. Everywhere else was left unsynchronized. So we created sort of a command base. It means that when you do all your external actions, your inserts, your update, your deletes, anything that needs to do by the user, actually, or even by the timer, goes into what we call a propagation queue. So now actually the engine is completely isolated from actions. It's impossible for you to, in theory, it's impossible to cause problems with an insert, update, delete, fire all rules, or fire until halt, because all they do is they create commands and they put them onto the stack. Putting the command onto the stack goes through a sync point. But actually, what we call flushing it, so if you do all your inserts, all your updates, all your deletes, and you call fire all rules, the engine will go to this stack. It goes through a sync point just once, takes the set of commands, and flushes them. So it means that the engine can do batch-orientated work, and the engine, which we want to make sure can work in efficient batches, only goes through one sync point. So we've managed to simplify our designs. We've managed to make sure that we have a good way to, if there are thread safety issues, we know exactly where they can be. And we've actually got performance increases from this, which was quite surprising. This also what we did was, because it's all now all command-based, we created proper semantics about what happens when you call fire rules or fire until halt, because it's kind of ambiguous. If I'm already running fire rules and midway another thread calls fire until halt, what does it do? Now actually the fire until halt will wait. It will wait until fire rules finishes, and then the fire until halt will resume and take over. So you have the ability for tasks to be able to be coordinated and for them to be able to be resumed and consume in a way now which it's not deterministic, but it's understandable. You can understand the behavior of it because it's documented and it's consistent. And I think it's the most important thing. If you call fire until halt, and if you were to call fire or rules while fire until halt is running, the fire rules is just ignored because fire until halt will never finish. One of the areas we had a lot of thread safety issues around timers. We had this ability to be able to have, if you're in fire until halt mode, if you're in fire or rules, which we call passive mode, and a timer goes off, some people want that timer to actually evaluate its rule and fire. Some people don't. So you have the ability for a timer to cause rule engine evaluation. So what happens if you then have the timer fire rules and fire until halt can all be trying to argue over who actually does the engine evaluation. So the state machine we have internally, without trying to go into too much details, make sure that's really efficient. And actually, if you're in fire until halt and a timer triggers, the timer you don't want to stop the engine because that's going to have performance problems. So actually the timer will submit the job and it will let fire until halt that's already running take the job and continue with it. If the engine is in passive mode, there's nothing going on, the state machine will allow the timer job to trigger the engine and cause evaluation. So, yeah. Right, so that's what I'm trying to get at now. So, so I should have stopped there. So remember I mentioned before that when something gets hold of the engine, because that's what the state machine is doing, whether the timer thread, whether the user thread from fire or rules, or the engine thread from fire until halt gets control of the engine. Only one can control the engine at a time, and the state machine coordinates that. When they get control of the engine, it does a flush of that propagation queue. The flushing of the propagation queue is when the bit masks are set, because that's when the inserts, the update and deletes propagate through the network. So we'll go through, all the bit masks get set, and once that queue is flushed, it will then go and see if any rules get to fire. I mean, this is really deep stuff, so feel free to fall asleep. I have some diagrams here which you have to put in the documentation that show, because we really want to try and get across to people now that the behavior of these things is not deterministic, but is understandable. We've put some flow charts together that show how those actually work. I won't go into the details now, but we've made a real effort to clean this code up. I've got 5 minutes left. Almost done. So we have also, and this is a part of the 7 series now, Mario is here, has been working on multi-core scalability. We're just doing immutable use cases because it's one that we can do, and it's most common for CP. So we really want to crack CP, complex event processing. The reason why that's got inflection points is because the graph is 12, 48, 192, 768. It's logarithmic, so you're just seeing the logarithmic there. But it's showing great scalability. As we increase the number of rules for these immutable cases, we're getting fantastic scalability. This is on a 12-core machine. We're going to be doing quite a lot of work around here. So we want to make sure that we can really scale well for the number of cores, for complex events processing cases, for the 7 series, which we haven't done that well before. This is in the 6 series, but it's not quite yet finished. I mean, you can use it. All of the DRL syntax side is done, but some of the back end isn't there. I'll explain why in a minute, but I'm first going to go over what OOPath is. So OOPath is based upon the XPath syntax, and it solves the ability to, rule engines are all relational. It means you have to flatten your model, and you have to explode it, and it's really quite painful. If I've got my Java Pojos, and those Pojos are a graph with nested lists and objects, I just want to insert that, and I just want it to reason over it. So what OOPath does is introduce an XPath-like syntax to look at graphs, and if the Pojos are properly instrumented, we don't do instrumentation yet, you have to implement it yourself, then it will actually have reactivity over the graph. So we have a hybrid graph relational system. So here, children is the list, and that will fire for each of the children of the adults. So it could fire 3 times. The / is a special syntax to say what's coming now is an OOPath statement. The next one is showing you that I have a man who has a wife. The wife has a list of children, and the children have a list of toys. And it works just like XPath semantics. So this will fire for every toy for every child. And that's going over you no longer have to explode your graph into a relational model. So this will allow Java developers to work with the model they have at their source. The dot there means that it's not doing list comprehension, because maybe I want to bind to the list. No, sorry, I got that the wrong way around. It means that it's it's not reactive. So I no longer want to have reactivity on the list of toys. I just want it to access it, and I don't want it to always react if the toys change. You can put constraints in there as well. So just like XPath, you can put constraints at any point in the graph. And you can control reactivity with the question mark there to say, I've got this XPath statement, but I don't want any of it to be instrumented with reactivity. You can put type filtering. So when you have a list of children, I only want the type of children that is a baby girl. Once it's done that type safety check, it means you can then access the fields of baby girl directly, because it knows now that that specific child is a baby girl and the fields are available for it. You have back referencing, so that you can reference other objects up the graph. And you have out of pattern usages as well. So it means you can work directly against variables, which is very useful for queries. Pojo-Rules. This is something still very early proof of concept we're working on. This is DRL, and this is the same thing in Pojo-Rules. This is pure Java. It doesn't need to go through any compilation stage. It allows someone to write rules with Java. It's much more verbose, but if you want to have Java, if you don't have a lot of rules and you just want to have some of the sort of reactivity relational aspects the rule engine provides, this is what we're trying to explore. How can we write rules with pure Java using lambdas? And again, this is Mario's work. And there's another DRL with a not this time, and the same Pojo rule. It's a work in progress, and this will hopefully become a major part of the 7 series. Finally, we have DRLX. I don't have anything to show for this. We're trying to work through a normal, what is the future of DRL? We don't want to have, DRL derived from, really from ilog, which derived from Lisp. And you can see all the quirks. It's ambiguous and it doesn't quite fit. It's kind of Java in places, but it's not great. So we want to start again completely fresh. And DRLX, we decided, needs to be a superset of Java. We're going to take the Java 8 grammar from Antler and use that as a basis and augment it, which means all valid Java will run, but we want to layer on top of it stuff that will allow us to have more succinct rules. This was an approach taken by the pizza language, which gave us generics. If you Google pizza language, you'll see this used a Java preprocessor. So it processes your, all of your language and outputs valid Java. And this will actually output Pojo-Rules. So we're going to develop the Pojo-Rules, but we're going to have a sort of a more domain-specific language. There's valid Java that's on top, but it will generate, will still be Pojo-Rules underneath. That's it. It's probably won't be available in the 7 series. We may make it available experimentally for those who want to try it, because we want to get feedback on it, but we don't want to rush it. We want to get it right. But this is what we think is really important for rule engines to have a future. DRL has to die. All right, any questions, please?